Hi, so it's Past Paper Friday. Today we're going to look at it's the specimen paper for the new specification of Edexcel AS Maths. So some of this, if you're looking at it and you're a GCSE student, you might not have come across it. But if you've learned the higher spec, you'll find a lot of it familiar. So this first question, we have a curve and you have to differentiate. Now, if you have done higher GCSE maths, you also will have, and further GCSE maths, you'll have learned how to differentiate. So this is straightforward differentiation. You bring the 3 down, so you get 2 times 3 to give you 6 x, and you take 1 away from the power. So 3 take away 1 gives you 2. And then you're going to do 2 times 2 to give you 4, and you take 1 away from the power. So 2 take away 1 just leaves you with 1. And that's like having a 1 there. And you know the gradient of 2x is just 2. And if you have any constants, they disappear. So now we've found dy dx. And then it says, hence find the range for which it's increasing. Now, when something increases, it's when the gradient is greater than 0. So what we're solving, and this is GCSE inequalities, is greater than 0. Now at A level, you have a calculator. And if you've got the class whiz calculator, you can actually just type in your inequality. So you go to menu, you scroll down to B, and you just literally put it in and it gives you the values. But let's calculate it as if we didn't have our calculator. So it's greater than 0, everything goes into 2, so we can divide through by 2. And when we divide through by 2, we get 3x squared minus 2x minus 1 is greater than 0. And we factorize that. Now, if you need some help factorizing it, you've got it, if I put it on the side here, minus 1 and say it equals 0, you'd borrow the 3, so you get 3x squared minus 2x minus 3 equals 0. When you, we'll leave the equals 0. When you factorize that, you've got 3 and 1, and you want minus 3 plus 1. You've got to give the 3 back. So you get 3x plus 1, 3x minus 3. You can divide this one by 3. So you end up with x minus 1. So we factorize this. We've got 3x plus 1, x minus 1 is greater than 0. Now our solutions would be, so our critical values would be, x is, so our critical values would be x is minus 1/3 and x is 1. But we want all the values when it's bigger than 0. Now, one of the easiest ways to do this is you can draw a graph. You might have learned a plus minus method, but I think the easiest way, obviously you have your calculator, is just pick a number between minus 1/3 and 1, and that's 0. I'm going to put it back into the original. So if I put 0 into the original, I get 0 minus 0, and then I end up with minus 2. Minus 2 is not bigger than 0, so we don't want 0. So that means we must want the outside range. With inequalities, it's either always be the middle or it's going to be the outside. So your answer to this is going to be x is less than minus 1/3 and x is greater than 1. But this question says it wants it in set notation. So in order to write it into set notation, it's exactly the same. It's the outside range. So if you remember from probabilities, that means x is minus 1/3 or x is greater than 1. And then what we do is we put these x double dot bits in. That's just the notation-y bit. And you draw some squiggly brackets around it. So that's writing it in set notation. So you take it as you normally would, but you put your or sign in the middle, and you do these x double dot bits. So that's question 1. And if you haven't, so that's question 1. It was an AS from the AS paper. So now let's have a look at question 2. So if we scroll up, I give you way too many bits of paper. Right, so you've got a vectors question here. Hopefully. Yeah, so you've got a vectors question here. Right, so the first bit tells you to find AB. Now, you may know as a rule that A to B is B minus A, but let's think about it. If we've got a point A here, going from the origin to here, that's called my vector A. And that's represented by OA in the question. If I've got a point B here, going from 0, 0 to B is my point B. Now, what we're trying to find is we're trying to go from A to B. And we say, well, how do we do that? So the road A to B is shut. We don't know what it is. But we could go from A down to O, and then from O up to B. Now, remember, when we go against an arrow, it's minus. So we're actually doing minus A plus B. So A to B is minus A plus B. And in general, when you have two letters, so when you've got A to B, it's always the second one minus the first one, which is the same as that. So let's have a look. What are these as vectors? B is 6i minus 3j, and we're minusing 4i plus 2j. If you find it easier, write them as columns. 6 minus 3, 2. So if we have a look at it as a column, we've got 6 minus 4 on the top, which is 2, and minus 3 minus 2 to give us minus 5. So on the top, that would be the same as 6 minus 4i, so 2i minus 5j. And that would be your final answer there. And then part B says, show that the quadrilateral OABC is a trapezium. So what does a trapezium look like? So if you were to have a trapezium, what's the shape of your trapezium? So your trapezium has a shape like, oh, go back to, okay. So your trapezium, let's just draw a trapezium here. So if you have a trapezium, you've got two parallel sides and then something joining it up. Okay, so there's a trapezium. So we need to prove that two of the sides are going to be parallel. So which two sides? Well, we don't know, so we could have a look. So if we were to label it O, A, B, C, O, A, B, C, sorry, we normally label clockwise. I've labeled anti-clockwise. Let's relabel that. So erase, if I take those out. So when you label things, I'm looking at it backwards, you should label it clockwise. So let's have a look. So hopefully, and I've done exactly the same thing again, haven't I? Oh, A, B, C, this is probably doing something live. Okay, so we're going to look at AB. Now we've already found AB, and we're going to compare that to OC. So if we take AB, we've got 2 minus 5, that's my AB, and my OC is 8 minus 20. And how have I shown? How can you see that they're parallel? Well, you can see that they're parallel because they're factors of each other. So if we were to times this one by 4, we end up with 8 minus 20. So we can say that OC, so if we write it out in full, the way you'd write that solution out would be to write, so let's just go, okay. So if we were to write out this solution, what we would say would be that OC is parallel to AB. And why is that? We said because 8i minus 20j equals 4 lots of 2i minus 5j. So that tells you that OC is equal to 4 times AB. Now, even if you'd labeled it wrong the way I'd labeled it, hopefully you would see that connection and look for the two sides that would be parallel. And so you'd say, hence, OABC is a trapezium. So in AS, and in particularly with the new A-level, which you won't find when you use the old A-level as practice papers, is that they like you to write all these words. When we mark the exams, you will sometimes want to give everyone full marks, but they've not written the full explanation, and the mark scheme insists on it. So that's question 2. Let's have a look at question 3. Okay, so let me just, okay, here we go. Question, gone too far. Okay, so question 3. So question 3, we've got a tank contains water, starts to leak from a hole in its base. The volume of water in the tank 24 minutes after the leak started was 4 meters cubed. The volume of water 60 minutes after it started was 2.8. The volume of water can be described, and here is where you come across your key word. So the key word that you need here is the word linear. So it tells you here it's a linear model. Now, what do I mean by a linear model? Now, all of you have come across straight line graphs. All a linear model is a straight line. So we know that all straight lines are off the form y equals mx plus c. But in this case, we don't have a y and an x, we have an m and a t. So we know this is going to be v equals mt plus c. And we need to find the m and the c. And if you have a look at the question, you've got enough information, because you know when v is 4, t is 24. So we can plug that in. So we can say 4 equals 24m plus c. And we know when v is 2.8, t is 60. So we've got 60m plus c. And you can solve those simultaneously. Now, again, at A level, you've got your calculator. Hopefully you've all got the Class Whiz calculator. If you go to menu, you go to equation, which is A, and you do 1, which is simultaneous equation. You pick number of unknowns as 2. You can just substitute it in, and it will give you your m, which comes out to be minus 1 over 30, and your c, which is 4.8. Obviously, at GCSE, you've learned how to solve these. It's a simple simultaneous equation, but your calculator does it for you anyway, and you won't need to write any working marks. You can go straight from these equations to writing your m and c. Don't forget, though, to rewrite the whole equation out. So don't forget to rewrite 1 over 30t plus 4.8. So now you've written out your equation. Okay, it says use this model to find the initial volume. You see the word initial, your brain's going to go, okay, that's the starting. So that's when t is 0. So if I make t equal to 0, I can straight away see that the volume is 4.8, because minus 1 over 30 times 0 plus 4.8, it will give you 4.8. And then it says the time taken. So here we're looking at time. So we want to find t for the tank to empty. So when the tank empties, what's going to be the case? So the tank is going to empty. Let's get rid of this so we can write here. So the tank's going to empty. When it's empty, v will be 0. So let's have a look what happens when v is 0. So if v is 0, oops. So 0 equals minus 1 over 30t plus 4.8. So I'm going to move the minus 1 over 30t to the other side, equal 4.8. And when I solve that, I'm going to do 4.8 times by 30. So t equals 144 minutes. And part C, and if you're not sure, it's just a 1 marker. It says suggest why a linear model might not be suitable. And here they're looking for anything that's common sense. You know, Think about pressure. The hole might get, you know, it might have more pressure, will leak more quickly at the start because there'll be more pressure, or the hole could get bigger. Something could get stuck. Just think of a logical answer why it might not be a perfect straight line, the amount of water that comes out each time. There were lots of acceptable answers. There's no right or wrong there. Like, there's no wrong really, as long as you've used some logic. Okay, so let's scroll up and look at question 4. So here we've got a graph. Oops. We've got a sketch of a graph. I'm going to see if I can make this whole thing. So you can see the whole question on one sheet. Right, so we've got sketch of a graph. And it's asked to state the turning points of 2gx. So if you remember from all your functions work, so if we take, so from functions, hopefully you remember or you recognize that if you have f(x) plus a, for example, so inside the bracket affects the x. The x's do the wrong thing, okay? They're like your ex-boyfriends or girlfriends or ex-partners. They do the wrong thing. So if it's plus a, it really does minus a. If it says it's multiplied by something, it really means you divide by it. So anything inside the bracket affects your x coordinate. If you've got something outside a bracket, it affects the y coordinate. The y's do exactly what they're supposed to do. So if it's plus a, it goes up. If it's multiplied by a, it just multiplies by it. But that's your y coordinates. So think of it as coordinates, and that's your x coordinates. So the x's do the wrong thing. So if we have a look here, we've got 2gx. So what we want to do, it first says, write the coordinates of the turning point. So my turning point is here. So it's where the curve turns. So that's 4 minus 1.5. So if we have a look, the number, we've got 2gx. So the value is outside of the bracket. So straight away your brain's going, this is affecting the y coordinate. So it's only affecting the y coordinate. This means the x coordinate stays exactly the same. So the x coordinate is just 4. The y coordinate is being doubled because it does exactly what it's supposed to do. Minus 1.5 times 2 gives us minus 3, and we're done. The next bit, part B, says state. So if you see the word state and you see it's 1 mark, it's supposed to be easy. If you're making it more difficult, if you're doing something more convoluted with it. So it says state the largest root of the equation. So we want to know a root. What does it mean by root? The root is where it crosses the x-axis. So the largest one where it crosses, is this 7. So what's happening to it? It's inside the bracket, so it's affecting the x coordinate. So the y coordinate doesn't change, which we know because it's talking about a root. So the y stays as 0. And what's happening to the x is doing the wrong thing. So instead of plus 1, it's minusing 1. So that 7 becomes a 6. And then it says state the range for when g dash x. So that's just a fancy way of saying the gradient. So if you see this dash, it's not the inverse, it's the differential. So it's the gradient. So it's asking you to say, when is the gradient less than or equal to 0? So when is it negative? So we think, okay, if I took a point here and I was to draw a tangent, that would give me a positive line. So everywhere here, there's a positive gradient. However, everywhere on this side of the 4, it's a negative gradient. because if I was to take any point and draw a straight line, can you see you get a negative line? So we know that x has to be less than 4. Okay, apologies, my phone rang. So that's going to be x is less than 4. So then it says state a range. So now if I clear it so you can see that last question, and if I scroll up, so it says, and if you can't see it, I'll read it out anyway. It says, given that the equation, so it's telling you, given the equation gx plus k equals 0 is a constant and has no real roots. So no real roots means it doesn't cross the axes. We can see here, this is outside the bracket. So it's saying it's as if you've moved the whole graph up by a certain amount. So how much do I need to move it up by so it has no real roots, meaning it never crosses the axes? So hopefully you can see that you want to go from minus 1.5 all the way up. So you're going to have to, k is going to have to be bigger than 1.5, because if you move the whole graph up by 1.5, you'll have no real roots and it won't cross the axes. Okay, so let's have a look at the next one. Just to anyone who's watching this on YouTube, because I've streamed it from Zoom, it's slightly out of sync and I can't see any questions. So you can see it live on the YouTube, but I won't be able to see any questions. However, please message me or put questions underneath and I'm happy to answer them later. Okay, so now we're going to use what we call the factor theorem to explain why f of x is divisible by x plus 3. So all that the factor theorem is, so a factor theorem is just, so what the factor theorem tells you is that if I divide it by x plus 3, there are no remainders. So there's going to be an exact answer when it's divisible by x plus 3. So what you have to do is you say, if x plus 3 was equal to 0, so if x plus 3 equals 0, x equals minus 3. And if we find out f of minus 3, it should be 0, and then we've shown that it's divisible. So f of minus 3, because it's a show that, write all your working. So write what you would type into your calculator to double check you've done it right. Minus 12, and we know that has to equal 0. And then this is it. Again, it's the explanation bit that gets you the marks. So you would have to write f of minus 3 equals 0, which implies x plus 3 is a factor, which implies that fx is divisible by. So I think it was last year's, maybe the year before's exam, in the AS exams, which we marked, loads of people did this step, right? There was a question very similar and everyone did that step and they all only got 1 mark because they didn't explain. They didn't write this explanation down. So that's really, really important. Then it says fully factorize. Now, there's a few ways to do this. If you've done this at school, you might have learnt long division. I'm going to show you the method I use, but it's totally up to you and you may have learnt a different method. So if we're going to fully factorize, so we're going to take x cubed plus 3x squared minus 4x minus 12, and we want to divide that by x plus 3. So I know it's going to go in at least 3 times. So x plus 3, or potentially 3 times because I've got an x cubed. So I'm going to write it out 3 times. And then I say to myself, what do I multiply? I want to get this x cubed. So I'm going to put x squared outside this bracket because I know when I open it up, I'm going to get x cubed. So when I open it up, that's what I'm going to get. So I'm going to get x cubed plus 3x squared. So now I have my 3x squared. So I've got my x cubed and I've got, in this case, my 3x squared. So the next thing I need is a minus 4x. So I'm going to multiply the next bracket by -4. When I do that, I get -4x minus 12, and I'm done. I didn't need this third one. You may need this third one if there's an x term. So now I can factorize that. I can see I've got x plus 3, and it's multiplied by x squared minus 4, because it's these numbers, these values here. Now, hopefully you recognize that that's a difference of 2 squares. So your final answer is x plus 2, x minus 2. Right. Now it says show that this thing can be written in a different form. So again, what we're going to do, let me erase down here so we can write it in the same place, is we factorize the top. So you've recognized, hopefully, that the top is exactly the same as all that work that you've just done. So you're able to rewrite the top as, you can rewrite the top as x plus 3, x plus 2, x minus 2. The bottom, you can take x outside the bracket, and when you take x outside the bracket, you're going to get x squared plus 5x plus x squared plus 5x plus 6. So if you were to factorize the bottom, you're going to get x, and you're going to get 3 and 2, and you're going to get plus and plus, and hopefully you can see that the x plus 2 cancels out. And what does this leave you with? So you've cancelled out the x plus 2, so you're left with x plus 2, and you can cancel out the x plus 3. So you're left with x minus 2 over x. Okay, excuse me, I'm going to go just grab my door. Here we go, that's what happens when you go live. Sorry, apologies, I'm back. So we get x minus 2 over x, and that's going to be the same as x over x minus 2 over x. So we end up with 1 minus 2 over x, which is in this form that we wanted. Hopefully that makes sense, and that's question 5. So we're going to move on to question 6. I've gone through this quite quickly, but this should just record and be on the page for you to go through later on. I'll try edit out me disappearing in the middle. Right, so if we scroll up, just stop, please. Okay, there we go. Oh no, I missed a question. Right, question 6. So those of you that watched the proofs lesson the other day should be happy with how we're going to do this. So it's only 2 marks, and we're using a counter example. So remember, we're using it, finding a number that doesn't work. So we're trying to show it's false. And it's also a little bit of exhaustion because they've given us a range. They've told us the numbers between 3 and 10. So you literally have to show that you've plugged some of them in. You don't need to plug in for all of them. You could plug in for a few. So for example, say I started off with 4. 4 squared minus 4 minus 1. 16 minus 4 minus 1 gives me 11. So it's not that one because that's prime. And then the actual answer is 8. So 8 squared minus 8 is 1, which is 55. And you'd say 55 is equal to 11 times 5. So it's not prime. And you're done. So you wouldn't have to show 2. You might be able to show all of them. It doesn't matter. If you started at 3 and had to go all the way to 8, just very quickly on your calculator, you find the example that doesn't work. And then we've got the next one, which says, prove the following statement is always true. The key here is we're saying it's always true. So the difference between the cube and the square, so we're looking at an odd number, is even. So if it's always true, we can't be using numbers. We have to use some algebra there. So what we're going to be using is we're going to use some values, some letters, sorry. So how do we represent an odd number? So we're going to let odd number be 2n plus 1. And we're trying to find the difference between a cube, so 2n plus 1 cubed. So difference tells us to take away, minus 2n plus 1 squared. Now, if you want to be able to open that out quickly, we can see there's a common factor. So the common factor here is 2n plus 1 squared, and that's been multiplied by 2n plus 1 minus 1. So if you were to open this out, you'd end up with that. I don't really need the big square brackets. So we can see this is the same as 2n plus 1 squared multiplied by 1 minus 1 is 0, multiplied by 2n. And you could open it all out and factorize and show you've got a factor of 2 outside, but hopefully you can see that you've got a factor of 2 outside. So you could say this is the same as 2n plus 1 squared. So it will be always even. Always even. Okay. The other way that you could have thought about it is you could have said a cube often, we're saying the difference of an odd number. So if you have an odd number and you cube it, so n cubed would be the same as n cubed minus n squared. You could take the n outside and you get n minus 1. And n squared is an odd times an odd. And here we've got an odd take away 1. Now an odd times an odd is an odd, but an odd take away 1 is always an even, and an odd times an even is always an even. So if you can think about odds and evens in that way, that's another way to do it. So there's 2 options, there's probably more, but those are the 2 that come to mind, and those are a way that you could do that question. Right, let's have a look at question 7. Okay, right, 6, 7. Okay, so we've got some expansions to do. Now, in your formula sheets that you'll get given, and I'm going to write it exactly as it, sorry, just leaning over to grab a formula sheet, exactly as it's given in a formula sheet. So the way that you were given, so in your formula sheet, you were given a plus b to the power of n equals a to the n, nc1 minus 1b, which looks really confusing, but is actually really straightforward, b squared. So we're just going up to the squared. So, and we could go further. Now that's going to be useful for part B. For part A, it's just a squared value, which hopefully you know how to do even from GCSE. You know, squared means multiplying it by itself. So you would end up with 1 times 1, which is obviously 1. And right. So we've got 1 times 1, so we've got 1 there. We've got 1 times 3 over x plus 3 over x plus 3 times 3 is 9 over x squared. Right. So when you've done that, you've got your, you can simplify that. So if you've got 3 over x plus 3 over x, that gives you 6 over x. So you've got 6 over x plus 9 over x squared. So hopefully that's nice and easy. But now we're going to try use this formula that we have to open up. I've given you 1, 2, 3, and it does give you the fourth, it just does plus dot, 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 using our formula book. So in this case, our A is equal to 1, our B is equal to 3/4 x, and our n is 6. So our first term is just a to the n. So it's just 1 to the power of 6, which is simply 1. Our second term is NC1. So on your calculator, on my calculator, it's above the divide sign. You've got this button that says NCR. So here, I'll write it here, NCR. And that's the button that you're looking for in order to press. So you would press 6C1, which gives you 6, times A, which is 1, to the power of 6 minus 1, which is 5. So 1 to the power of anything is 1, so that's just 1, times by your B, which was 3/4 x. Okay. And then the next one would be NC2. So when you type NC2 into your calculator, you would type 6C2 and your calculator gives you 15. And then again, it's times by 1. I'm going to stop writing the times 1. And then it's my B all squared. So it's 3/4 x all squared. Now that's really important. That's why I've put that B in brackets. It's the whole thing squared. And the fourth term, so if you follow the pattern, you can see you're going to have 6C3, which gives you 20. And now you're going to times it by 1 to the power of something, which is just 1. But then you're going to have 3/4 x cubed. So can you see how it goes up each time? 1, 2, 3. And then you simply simplify that. So you simplify each term. So you're going to get 1 plus, that's a plus, okay, 6 times 3/4. So 6 times 3/4 is just 9/2. And then you've got your x. The next one, you're going to do 15 times 3/4, but the whole thing is squared. So it's going to be 3/4 all squared. And if you put that straight into your calculator, you should get 135/16x squared. And in the next one, you're going to do 3/4 all cubed. So when you cube 3/4 and times it by 20, you also get 135/16. And you've got x cubed. Okay, so now you've got to find the coefficient of x when you multiply these two things together. So this one and this one. So if we notice, in this one, the x's are on the bottom. In this one, the x's are on the top. So when we multiply them together, you can almost think about it. You can say, okay, I can do 1 multiplied by this whole thing. So the only bit that I want to be able to get the x is going to be this 9/2. So we've got the 9/2. Then if I've got 6/x, if I times it by 1, it's going to give me something with 6/x. If I times it by the next one along, it's going to cancel out the x's, and so there's going to be no x value. The next one along, the x and the x squared will cancel out to give me x. So I know I'm going to need 6 times 135/16. And for the 9 value, 9/x squared, we need to have 1 power higher to be able to cancel out. So that's also going to be the x cubed term. And when you stick that all in your calculator, you get this horrible number, but it's the answer. So you get 2097/16. Right. So we've got about half the paper remaining. So what I'm going to do is stop there and then look at question 9 to 14, but I'll upload this as the whole paper altogether, and go through 9 and 14 as a whole paper, which you will oh God, which I'll upload just now. So I'll put the first half up now, and this will stay as the live stream of it. And then question 8 to 14, I will add to that, and you'll be able to see the whole paper as you go through it. I'll try go through it slowly as well, but hopefully that's useful. Those of you, if anybody is doing GCSE, I'm going to be going through a GCSE chemistry combined science paper at about 12:30, and I'll go through a higher GCSE paper, going through, starting probably with the more difficult questions. I'm not sure, I think I might start in the middle or at the back, a higher non-calculator paper for Edexcel. But no matter what board you do, it should be useful. Take care, and I hope that was useful.